Now have the pleasure to introduce our next speaker, and our next speaker is called Nicolas Spethmann. Dr. Nicolas Spethmann, you are the head of quantum technology, the Quantum Technology Competence Center, QTZ, at the Physikalisch-Technische Bundesanstalt. I don't know the English translation of that, but I'm sure you do, so please feel free to share that then. And so we've now seen a general overview about standardization activities by Marius, and so now Nicolas, you will go into specific needs, challenges, and strategies for developing standards for quantum computing. Last but not least, since this year, you are the vice chair of the Standardization Joint Technical Committee 22 Quantum Technology that we have seen before. Thank you again for being here, and the stage is yours.
Yeah, thank you very much. And I will try to continue exactly where Mario stopped with his presentation of the general structure of standardization. And I actually would like to answer your question that you had here in the front. So I'm very happy to discuss about this. And I will address in the very beginning the question if it's too early for standardization. But before doing that, maybe let me just say a few words where I come from and what we do have to do with quantum technology. So I'm from Physikalisch-Technische Bundesanstalt, and I would say, indeed, this is also not translated. So I'm not sure if I would translate Quantentechnologie Kompetenzzentrum, doesn't matter. So our main task is to provide the national measurement infrastructure in Germany on an international competitive level. So we are the National Metrology Institute. You could also say, in other words, we are responsible to define what a second is, what a meter is, and so on and so forth. So the question is, what does that mean, and what does it have to do with quantum physics and quantum technology? And for this, I brought this slide here. So if you want to create a machine that tells you what a second is, you need to build a machine that's obeying quantum physics, basically, to give you what a second is. So that is, in other words, quantum technology. And this is indeed what we do when we build up, research, and develop atomic clocks and define a second. So this technology, in some cases at least, is very strongly related to ion trapping, which is one of the possible base technologies for quantum computing. So as you can see, there's a very close connection here. And we have this expertise by definition at PTB. And we also have infrastructure to do that on a high level. The same goes for electrical quantum metrology. We have Josephson voltage, Josephson junctions that define the volt, which are related to superconducting quantum computing devices, and the same is true for photonics. I don't want to say much more than that. I could talk much longer about quantum mechanics if you wanted me to. I just want to make the point that that's the reason why the Competence Center for Quantum Technology from the federal government is situated at PTB, because we have all of this under one roof, and we try to use this to support industry with a lot of activities. I would say a lot of it is metrology, test and measurements for quantum technology. And I'll give you you did ask this question, shouldn't we do implementing? I would say this is happening. A lot of money is invested, and we need a quality infrastructure, including standardized measurements. And I'll show some examples about this. Okay, so this is where I come from. I will now change gears a bit after I drink a bit of water. And as was mentioned, I'm by training a quantum physicist, but I'm also the co-chair of the JTC22. I will say a few words about this. So we are also supporting standardization in that sense. Marius gave a great introduction. I just have this very dummy slide on standardization that I copied from Wikipedia. Just to repeat this, what we're talking about are technical standards, so a piece of paper indeed, where we write down something about some components, and I'll give you examples about that help to maximize compatibility, interoperability, safety, repeatability, and also quality. And now the question is, of course, what do we write down? Is it now the time to do that? And does it make sense to do it? And again, Marius gave us a great overview, and I will try to give you a two specific examples what's happening right now in the standardization community, and also make a connection to what we heard from Gustav Kalbe before about implementation. Okay, so now to the question, at which point should we start with standardization? Should we wait until we have a quantum computer and the software seem to converge to something? That was the question we heard here. So to answer that question, I would look at the technology readiness level for quantum technology and in particular quantum computing. And I'm sure you all know this. You start at laboratory work, basic principles, go all the way down to actual systems proven through successful operation. So now the question is, at which point should we standardize? And if you look into this graph here, already here, it is very important to standardize, or at least think about standardization for terminology. What are we talking about? What is a qubit? What do we mean by a coherence time? What do we mean by fidelity of qubits? How do we actually measure that? Do we trust the company that's creating this qubit and tells us the fidelity is whatever percentage? Or shouldn't we have standardized measurement methods that can be carried out by other people, other institutions? So this is very early on, and I'll give you specific examples in a few minutes. Then, of course, if you go on, you will have standards for components, physical interfaces, quality metrics. How do we measure performance of quantum technology components? That's a non-trivial task. And then it goes on to high TRLs, protocols, data models. I have to say I'm a physicist. I don't know much about this. I won't talk about this today, but of course it will play a role at some point. Okay, so the key message here is, from my point of view, and now I'm talking as the vice chair of the standardization committee, it should be, standardization should be thought of at least at an early stage. I'm not saying everything should be standardized, but there should be a educated consideration what to do. It does affect the complete life cycle in many cases, and of course there's also a political component. I think we heard about this in this very session before. We heard about this point. I will not say much more about that. Okay, so one thing that is close to my work is quality metrics and measurement methods. And, oh, sorry, before I come to that, let me first of all say where I take the examples from. I will show you now 2 examples, or 3 examples. And I'm now talking again as the chair of those initiatives here, so this is not my idea or my work, it's really the work of those committees here. And Marius told us how this works, right? So this is like a group effort that comes out of those committees. And on one hand, we have the focus group on quantum technology, quantum technologies, it was mentioned before. It was active, I think, from 2019 to 2023. It now stopped working, and the main output is this roadmap and also an overview paper. And the work of this focus group went over then to this actual joint technical committee that Marius already mentioned, which was established this year. I think it's very nice to see that the management is done by Germany and the Netherlands, and then we have several working groups working on different topics, domains of quantum technology, and the conveners are, large countries from Europe. I think this is a very good development. Okay, before looking at JTC 22, let's just have a look at, one example from the roadmap from the focus group, and this is shown here. So the idea here was to give some consensus idea from the European community. What are the things that should be standardized on and on which time scale? And I think if you look here, this is topics versus time, so this is about now maybe. And then you have, as I said before, parameters and testing. You have then small series production, in the end, maybe mass production. And as you can see, this aligns to some extent with what we saw before from Gustav Kalbe and Tommaso. So, and again, you can see the main topics here are terminology, definition of metrics, and then also test infrastructures. And please allow me a short detour, because again, as I said, I'm a physicist and I'm working at PTB, our National Metrology Institute, so measurements and quality infrastructure are very important for us. And this program has been mentioned already today. So this is a European project that is actually exactly living in this regime here. And this is about bringing together people from institutions from all over Europe for a federated network for testing independent tests and measurements for quality. And the same people, in some cases at least, are active here that can also contribute to standardization. I just want to give you a brief flavor because this is an implementation bit. I mean, this is happening now. What's happening here? What is relevant for standardization? This was already shown by Gustav Kalbe. So here you can see we have partners from all over Europe in the different domains of quantum technologies. I don't want to go into any detail here. I just want to focus onto quantum computing, the activities on quantum computing, and show one of the activities we are also active in. So what we're doing here is we come up with harmonized testing protocols. You see technologies that are present in this large consortium here for unified tests, traceability, and reproducibility. And the main idea is really to have a reliable supply chain for the quantum ecosystem. As you can see, this is a certain combination of partners. And just to make it very specific, I brought you just a photograph from the laboratory at PTB, which is only one point in this whole consortium. This is a so-called user facility where you can now test and characterize ion traps, basically from external partners. And this is actually happening now. And this is, I think, very important to say that this is an initiative where you can get independent measurements of quantum technology components. Okay, so this was the detour. What does that now have to do with JTC 22? And for this, I want to look with a little bit more detail into two of the ongoing projects in JTC 22 that Marius already mentioned. So one is called Characterization of Quantum Technologies, Metrics and Terminology. So as you, I hope now can take away from what I said, this is exactly relevant to the machines that are now built up all over Europe for characterization of components. And this is a list I just copied from this project. And as you can see, it mentions quantum computing, including measurements and characterization, 4 qubits, quantum logic gates, and so on and so forth. So this is one example. So this was a strong focus on characterization and metrics. Let's look at another example. And here you have the software you were talking about. So this is another ongoing project. As mentioned before, this is really just happening now, so it's not ready yet. And this is called Layer Model of Quantum Computing. And if you look at the right-hand side, what this is about, it really is an abstract description of quantum computing systems via a common stack of layers. So you might even say it's a bit of trivia because you just say, okay, you have some certain kind of layering here. But indeed, the idea here is to have a consensus about how you can think about this. And the way this is organized, you have different layers here. You have certain hardware implementation that might all come with different requirements. And the point now is that you can define with this kind of picture, and of course there's more to it than this, you can define a common language that can be used to describe features, functional requirements for each of those layers. And you can also analyze and describe interactions between those layers, including, if you want, just say, okay, we don't know what's happening on top here. In principle, so the yellow color should say that this is also meant to be agnostic. So ideally, this shouldn't depend very much on the underlying layers here. But of course, now you can try to define the connections here. But of course, you can also say it's not ready yet, but you still have this layer model defined. And down here, you can already think about different parts here. And I want to mention another thing. If you say, sorry that I'm putting you on the spot here, but if you say why should we do this now? I mean, the government of this country is investing more than 2 billion euro, right? And the European Commission is investing even more. Shouldn't we think about a quality infrastructure so that we can make sure that we can, I mean, there's technology development going on in all of those here, and we need independent quality infrastructure to measure those things and to compare those things, also in terms of performance. Okay, so finally I want to come to another point, but just very, very briefly and try to leave a little bit of time for questions. A picture like this can also be helpful to at least get first light or think about benchmarking. And if you think about this picture here, and this is now taken from the roadmap, in the roadmap, the community came up with those two approaches here. So you can have either have a top-down approach, where you have some kind of algorithm running somewhere up here that will give you characteristic performance indicators of your system. So in the easiest case, this could be a software just operating one gate and you get some properties. Of course, it could also be something much more complex, like an application, and you look at how fast it is. And then the question is, how do you compare that, right? I don't know, but that's one approach. It has the challenge that if you run something on here, how much do you learn about all of those layers? Maybe you don't need to, okay, but that's one of the challenges. The other approach is bottom up, so you basically measure in a physical kind of way properties of building blocks in the lowest layer here, and if you want to, you can even have traceable measurements that give you, reliable parameters of your components down here. Okay, so I think this is a very relevant open question right now, how to do this. My point here is that if this would be a agreed, technical report at this point, it might help, to build on this for benchmarking and for other things. Okay, so with that, I would actually like to stop where I started, kind of. So I showed you this TRL picture here. So I showed you these two examples here. I should say those are focusing on general Qt, but also on quantum computing. As we have seen from Marius, there are also a lot of other projects dealing with quantum communication, sensing, and so on. I just focused on two, I hope, interesting examples. I would state that they live somewhere up here without, knowing where exactly. But I think this is why it makes sense to think about those already now. And with that, we have 3 more minutes left, I think, for questions. I'm happy to take your questions.
We have time for questions. I have a microphone. Who is raising their hand? Let's go. Asking the first question is usually difficult, so I encourage you. There we go. Wonderful. Thank you very much. I'll try to run.
So hello, thank you for the nice talks, also the previous one. Actually, it's not really a question, it's really, I would like to add that I'm from Fraunhofer Society, and we have a huge offer of technologies from microelectronics, photonics, microsystem technologies, processes also which we can offer to help the community to build their quantum computing hardware and also software from other departments in Fraunhofer. And for even inside of our own association, it is very helpful to have this structure and to agree on a common terminology. So I unfortunately have to take the train now, but I'm really looking forward to get in touch with you guys. Yeah. Thanks.
Wonderful. Thank you so much.
Thanks, Tim.
I think we have 1 or 2 more minutes, so if there's another question, and now is the time. Else, you're also available for a few minutes afterwards, I think, so there's still time to exchange.
Yes, thank you.
All right, thank you. This is your applause again.